Today we'll learn how to solve an exponential function in a method other than guess and check. So our first problem, zombie alert, SLP High School, which has a student body population of 1,427, has been infiltrated by zombies. It started with one zombie. The next hour there were 3 student zombies. Then the hour after that, 9 student zombies, and so on. If it continues at this rate, how long will it be before the entire student body is a zombie? How long do we have? And we can see that we're multiplying by a number every time, so this would be an exponential function. And if you recall, for an exponential function, we have y equals ab to the x, where a is the starting value, b is your rate of change, and x is time. So let's plug in what we know. We know we started with one zombie. And we know that it's tripling every hour. 1 times 3 is 3, 3 times 3 is 9, and so on. So it's tripling every hour. So here's a function that could stand for the situation. And we also know that the student body population is 1,427. So we can make this equation. And before, we've solved this using guess and check. So we would just type in numbers. 3 to what power is 1,427. So let's try that one more time. And then by the end of the lesson today, we'll figure out another way, an algebraic way, to solve for x when it's the exponent. So in my calculator, I'll just type 3 and I'll pick a power. Okay, so let's clear this out. All right, so let's do 3 to the power of, I don't know, let's see, 5. Okay, that's way too small. It's 243. So we have to go higher. So I'll pick 9. Oh, that's way too high, right? We're looking for 1,000, and I forgot the number already. 427, I think it was. Oopsies. This is the wrong packet. So 1,427 is what we're looking for, and 9 is way too high because it gives us 19,683. All right, so let's delete that. Let's try 8. Okay, it's getting a little bit smaller. Let's try 7. We're getting closer. 6. Okay, so it's between 6 and 7. Okay, so it's a little bit higher than 6 point. Okay, a little bit higher than that. Okay, so this is pretty close. That's even closer. All right, so we're going to say a little over 6.5 hours, right? I'm pretty close there. This is 1,424.8, and I want 1,427. So we're like 3 people off, and so I'm going to say it's about 6.61 hours. So x is about 6.61 hours. You probably got closer. That's good. All right, how can we check our answer? Well, we could check it graphically. So if we pull up Desmos, we can type in the function. So y equals 1 times 3 to the power of x. Okay, so there's what our function looks like. We can see it's exponential. And we want to know where it meets the student population of 1,427. And the reason why we don't see it on our graph is we have to change our domain and range, right? This graph is only going up to 9 and then 10 in the x direction. So I'm going to go to this. First, I'll change it to projector mode. And then I'm going to change my x and my y-axis. So I know the time. I'm going to just go out to like, I don't know, 20. You know, the answer is like 6 point something. But the y-axis is really what we got to change. We got to go a lot higher than what we're at. I'm going to go up to like 1,500. Okay, so let's see if we can see our graph. Oh, yes, we can. All right, so again, the red graph is the zombies increasing exponentially, and the blue line stands for our student population at 1,427. And if we click on it, oh, look how close we were, 6.611, and then you see it's 1,427. I had 6.61 without the other one. All right, so you can check your answer graphically. We can type in the function. If we know what we want it to equal, we can type that in as well and see where they cross, the point of intersection. Okay, so graphically, just where they crossed. Part 2. All right, so now we're going to learn this algebraic way to solve a log. And to do that, we're going to look for patterns of what we notice. So it says, take a guess at what these statements are saying. So we have power 2 of 8 equals 3, power 2 of 32 equals 5, power 3 of 9 equals 2, power 3 of 81 equals 4, and so on. So see if you can find a pattern. Here's Here's some more of them, and if you know the pattern, see if you can fill in what's happening. So again, take a look at these. What do these numbers have to do with each other? All right, and I'm going to start with the one with the smallest numbers that maybe are more familiar. So I would say this middle one is a good one to start with because we're looking at these numbers, the 3, the 9, and the 2. And so my question would be, how are these numbers related? So for example, the 3 and the 2, how is that related to the 9? So hopefully you're noticing that, hey, if we take the 3 and we square it, we get the 9. Let's see if that works for some of the other problems. So let's look at the bottom. If we take this 5 and we square it, we get 25. Okay, how about like the top one? What if we take 2 and go to the third power? Do we get 8? And yes, we do. Let's try the next one. 2 to the fifth power. Is that 32? And it is. So what we're noticing here is a pattern where you take this number, the small little number, to this power to get this number. So this is saying 2 to what power is 16? And that would be 4. Try this one. 6 to what power gives us 36? And that would be a 2. 6 squared is 36. How about this one? 5 to the third power. What does that equal? Well, that's 125. And this one right here, 2 to the negative 1 power. What is that? And if you recall from properties of exponents, if you have a negative exponent, you can flip it to the bottom. So we're going to get 1/2. All right, let's go over just a few more of these. Well, let's skip these for now. We'll get to these. But that's kind of our pattern there. So then my question is, how does this black box differ from this one right here? And the only thing that differs is instead of the word power, to the power of, we're using this word logarithm. All right, so again, 5 to the second power is 25. 3 to the fourth power is 84, but now we're replacing it with this logarithm right here. And the reason why we're doing that, now we can shorten it even more, instead of logarithm, we can actually write it as a log. And the reason why we're doing that is it's a logarithm is the inverse of an exponent. So the inverse is like the opposite. So example of inverse is the opposite or the inverse of adding is subtracting. The inverse of multiplying is dividing. The inverse of an exponent is a log or a logarithm. And what it does is it undoes the exponent so that we can solve. Just like when you're trying to get rid of a plus, we subtract. When we're trying to get rid of something that's being multiplied, we divide. When we're trying to get rid of something that's in the exponent, we will take the log. All right, so if we take a look at it, there's two forms here. There's the log form and something called the exponent form. So let's write that here. So this is the exponent form here, or exponential form. All right, and again, this is log form here, a logarithm form. All right, so see how they're related? Here, if we take 2 to the third power, we get 8. We get the exponential form. All right, and we should be able to go the opposite way as well. So this one, it'll be log, and we say base 2 of 32 equals 5. And so we'll take a look at just writing the different forms. So by the end of today's lesson, we should, number 1, be able to go from log form and exponential to exponential and exponential to log form. And number 2, we'll learn how to solve with these logs. All right, so first let's start with something we know. We know exponential form. We know the base. We know the exponent. So 4 to the third power equals 64. To write it in log form, it's really easy. We're just going to make a loop. We're going to say log, and we're going to start at the base. So the base is 4, and the base is a little number here in your log. So log base 4, and then we're going to make a loop of 64, and we write 64 big. Then we're going to put an equal sign, and we're going to write 3. So again, log base 4 of 64 equals 3 is how we write that out. Let's try it with the next one. Again, we write the word log. It means logarithm is the inverse of an exponent. And we look for the base. The base is the little number. So here's the base. So we say log base 3 of, and we make a loop. Log base 3 of 1 over 27, and we write the 1 over 27 big. We put an equal sign, and then we put the exponent. Okay, so again, we start with if we have the exponent, we say log, and then we put the base as a little number. We make our loop, so of 64 equals 3. Let's go the other way. And the other way, again, we're going to start with the base. It's all about the base, right? We're going to start with the base. We're going to start with the base, and we're going to say 125 is the base to the power of 2/3 equals 25. So again, we start with the base. Here the base is 8. 8 to the power of 1/3 equals 2. So you should be able to go from one form to the other, and you always start with the base and make a loop to get each of the forms. All right, so the first half of your assignment is changing the forms. So if you have questions, you can look back at these forms. You have to be able to get to log form from exponential and to exponential form from log. And then the second thing is, how can you solve an exponential equation using a log? And we have to use this formula. In most calculators, unless you have, like my calculator here is a TI Inspires, a fancy graphing calculator, and log form is already built in. But for most, especially if you're like on your phone, we have to learn how to use change of base formula, and that's this. All right, so again, this is going to help us type it in. Log base b of a is the same as log of a over log of b. And so we'll practice typing that into the calculator. Okay, so let's practice just solving. Solve for x. This is an exponential form. Let's change it to log form. So we're going to say log base 3, and we're going to make our loop of 1427 equals x. All right, so there's log form. And then change of base formula is log. So again, here's change of base formula. It's log of the second number over log of the base. Log of the base goes on the bottom. Think base, basement. All right, so this will be log. So here's how we type in our calculator. Log of 1427 divided by log of 3. All right, so we're going to type that in. And that is an inverse of the exponent. So it's like to get rid of adding, we subtract. To get rid of the exponent, so again, here x is the exponent. We're going to use a log, and we're going to get our answer. All right, so here's how you have to type it in on an iPhone. You have to type in the number first. So if we're typing this in, you type in 1427 log divided by parentheses 3 log. If you have the scientific decimals, let's practice typing this in. I haven't tried it yet, so let's find it. All right, so I'm going to hit this button, this function button right here, and see if they have log. Oh yes, log is down here, kind of middle near the bottom. All right, so I wonder if I can hit log first. Yes, you can. All right, so we're going to do log of, I have to go back to main here, 1427, and then close my parentheses, divided by log, so go back to the function button, of 3. So I have to go back to main 3. And there it is, that number that we had before from the zombies. Should make this bigger. 6.61. So again, it's log of the second number over log of the base. That'll give us our answer. All right, let's try some more. All right, so now we don't have to use guess and check anymore. Let's solve for x. X is the exponent. The first step, get rid of the 4 by dividing each side by 4. All right, so let me type this in. 4,650 divided by 4 is a decimal. It is 1162.5. That equals 10 to the x. Okay, now, all right, so again, I didn't clarify, I'm sorry. So in order to use a log, you do have to get x by itself, or the base and the exponent by itself first, and that is why we divide it by 4. So if you have that number on the outside, divide to get rid of it. Now we have this. When you have the base and the exponent by itself, now we can put it into log form. So we're going to say log base 10 of 1162.5 equals x. And now we can type that in. Again, in your calculator, you will type in log of 1162.5 divided by log of 10. If you have just like your iPhone calculator, you have to type in the number first and then use parentheses like around the second log. All right, so let's type this in. If I could just go up here and delete it, yep. Okay, 1162.5, close my parentheses, divided by log of 10. And my answer, you can see over here, is 3.065, approximately. So I'm going to say x is about 3.065. Okay. Let's look at problems that we've already done this unit by guess and check and use logs to solve. And then I'm going to have you practice writing it in the different forms and then solving them with logs. Okay, so example 3, again, a problem we've already done before. Most cars depreciate or lose value as they get older. Suppose you buy a car for $25,000 and it depreciates by 1/5 of its value every year. So 1/5 we can change to a decimal. 1 divided by 5, that's 0.2. Write the exponential function that represents the situation. All right, so we have y equals, we start with $25,000, the value of our car. The value is depreciating at 20% per year for a certain number of years. So there's a function that can represent this. I can simplify it, right, because we know 1 minus 0.2 is like $1 minus 20 cents, that's 80 cents. Okay, and I also want to know when it's worth half of its value, so half of 25,000 is 12,500. All right, so here's my function. Let's solve using logs. So the first step is get the base and the exponent by itself. The base has the exponent attached to it, so it's going to be 0.8 to the x. And so we have to get rid of the 2,500 by dividing each side first, or 25,000, I'm sorry. So then when we do that, we get 0.5 equals 0.8 to the x. So again, 12,500 divided by 25,000 is half. All right, now let's use a log to solve. You could use a guess and check, but now let's log it. So we're going to say log base 0.8 of 0.5 equals x. And now we'll type that into our calculator. I'm running out of room here, so I'll show how I will type it in down here. It'll be log of the 0.5, the second number, divided by log of the 0.8. And we'll type that into our calculator. All right, so I'll just try to go up here. So log of 0.5 divided by log of 0.8. And we can see it will take 3 years, about a little over 3 years, to lose half of its value if it depreciates at 20% per year. So 3.1 years to lose its value. Okay, let's try another problem that we've done before with guess and check, but now we can use logs. An initial deposit of $500 is invested at 8.5% interest compounded annually. How long will it take until we have $800? All right, so 800 is the end result. We start with 500. It's growing at 8%, 8.5% annually. So a simple interest problem looks something like this. First step is I would divide each side by 500 to get the base and the exponent by itself. Is that a nice, yeah it is, okay. So 800 divided by 500 is 1.6 equals 1.085 to the x. All right, once you get the base and the exponent by itself, we can log it. So it's going to be log base 1.85 and then loop it around of 1.6 equals x. And we'll type that into our calculator. So I'll show you what that looks like. It'll be log of 1.6 divided by log of 1.085. So again, log of the second number over log of the base. And it will take about 5.76 years for our $500 to grow into $800. Oops, 5.76 years. All right, so x equals 5.76 years. That's a very good interest rate, of course, 8.5%. All right, in the last example, it says the common log has a base of 10. The common log is used to measure acidity, sound in decibels, and earthquakes like the Richter scale. Whenever a log is written without a base, the base is 10. So this is kind of like saying like whenever you write an x, that's the same as 1x. Now we're saying whenever you have a log without a base written, the base will always be 10. So when you see this problem, you can put a little 10 there, and then we can change it to exponential form. So base 10, the exponent's 4, equals 10,000. And that would be how to change your log form to exponential. So again, when you don't see the base, it's base 10. All right, so your assignments for the next 2 pages, it is switching forms and then actually trying to use logs to solve.